One last topic before we move into the physics of the body and the applications, and that's on the methods of heat flow. We have three methods that heat can flow from one object to another. Those are conduction, convection, and radiation. Conduction requires contact between two objects. In particular, we need thermal contact between two objects. When we talked about the campfire, we have thermal contact fire between the camper and the fire when we use, say, a metal rod, which has a high rate of thermal conductivity. Uh, so an object doesn't have to actually be touching another object. They can still be in thermal contact. So if, say, I have an object A and I have an object B, there are two ways for these objects to be in thermal contact. They can just be touching one another, like this, or they can be connected by some other object that allows for heat to flow from one object to another. So conduction is described in this way. The heat per time, that is in joules per second, Q over T, is equal to K times A times delta T over D. This Ka delta T over D, the delta T refers to the difference in temperature between objects A and B, referring to this figure right here. D is the distance between the two objects. So I'm referring then to this distance. So I have some material that is putting these two objects within thermal contact. A is the area, the cross-sectional area of the object. So the area would be like this area right here, the cross-sectional area of the material that is providing the thermal contact. And then K is the thermal conductivity. Thermal conductivity, we saw that in the video, the Veritasium video, I did a demo in class. The thermal conductivity describes how thermal energy moves through an object. Or a material. So different materials have different rates of thermal conductivity. Wood, for example, has a relatively low thermal conductivity. Most metals are very good conductors. They have relatively high thermal conductivities. So, for example, if you want to defrost meat, I don't know, ground beef or steaks or chicken or whatever, it comes in this foam tray. A foam material has a very low rate of thermal conductivity. It doesn't conduct heat away from the chicken or the ground beef or whatever the meat is very well. So if you leave it in that tray, then it's not going to conduct heat out very easily. It's always better if you want to defrost it quickly is to take it out of the tray and put it on a metal pan, and then you'll feel the metal pan it's very cold, and that's because the heat is being taken away from that frozen item. So if you ever want to defrost an item of meat or some other object, then put it on a metal tray or a metal pan. It'll defrost much more quickly. Okay, so you have three different ways: conduction. Convection requires the flow of a fluid. For example, in a convection oven or in a barbecue grill too, we'll have a convection flow. So if I have a convection oven, what I have inside of that is not just heat from the elements, but then you also have a fan that provides the flow of a fluid, and then whatever you're cooking will cook much more quickly because it has this heat transfer through convection. And then finally, radiation, which is the transfer of energy by light waves. or electromagnetic waves. We'll have a whole chapter on these, so we'll talk about these later. So when I think about an oven, actually, ovens operate primarily through radiation, unless you have a convection oven. So when I have a convection oven, it adds in this second method of energy transfer, which causes your food to cook much more quickly. So if you have a convection oven, or as I said, a barbecue grill, for example, has convection because you have a flow of air around the material. Items will tend to cook much more quickly. In fact, if we just had Thanksgiving, if we have a turkey and you try to cook it in the oven, it's going to take 4, 5, 6 hours. But on a barbecue grill or in a convection oven, it just takes really a couple of hours. Right, 3 different methods. Make sure you know them. For the conduction, make sure that you know how the rate of conduction is dependent upon these different variables. Okay. Recognize also that the cross-sectional area is pi r squared if we're talking about a cylindrical material. So if I increase the radius of this, it's going to increase the area by a factor of 4, which would increase our rate of conduction also by a factor of 4. Okay. Make sure you understand convection requires the flow of a fluid, like in a convection oven, and then radiation is just the transfer of energy by light waves. So if I have, say, a fire, and then I have a person that's standing over here, there is no convection from the fire. Most of the radiation most of the heat that you feel comes to you in the form of radiation.